In the real world, there are a massive number of objects and people, and they are experiencing all sorts of events in various situations. Sensing these situations and understanding the events can make a big contribution to achieving a ubiquitous society. The S-Room project at NTT Communication Science Laboratories aims to achieve such a society by developing techniques for making data collection more efficient at sensor nodes, such as by decreasing the amount of calculations and data transmitted via wireless communications and reducing measurement errors. It is also developing technology for inferring human behavior from data collected by wearable sensors. For example, we can consider sensing in an indoor environment. Here, data is transmitted by wireless communications. If data from each sensor was to be transmitted directly to a base station, a huge load will be applied to the transmission band and the base station. But since the data measured at neighboring nodes are similar, data can be grouped and transmitted in a multi-level hierarchical manner. This makes the process of data collection more efficient. In addition, much of the data at each sensor node possesses periodicity. Also, sensor data divided into periodic segments possesses similarity. By applying SVD to the data, they are broken down into base sequences that represent common changes in the original sensor data and difference information for each segment. From these base sequences, only those which provide good representation of the original sensor data are transmitted to the transmission destination. Later, by transmitting just a small amount of difference information, data, which well approximates the original sensor data, can be reconstructed. This process can be performed at each terminal and at each level, resulting in a major reduction in the amount of transmitted data. In this demonstration, the yellow blocks represent the amount of original sensor data, and the green blocks represent the amount of data transmitted by the proposed technique. For example, air temperature data can be compressed from level 1 to level 6, and data nearly the same as the original sensor data can be reconstructed at the base station. Compared to conventional techniques like the Fourier transform, the proposed technique significantly reduces the amount of calculations and transmitted data. It also minimizes the amount of power consumed by batteries at sensor nodes. Technology for sensing and recognizing human behavior focuses on the fact that most human actions involve use of the hands. With this in mind, we have developed a wrist-worn sensor device, and by equipping it with a camera or acceleration sensor, we can infer complex human behavior. For example, could this system recognize the act of making a cup of cocoa? We can say that the system is successful if the movements of the user are mimicked by those of the avatar. For behavior that is difficult to identify using only acceleration and orientation, we can add color information from a camera and apply a learning model to recognize the act of making a cup of cocoa. The movements of the user can then be reflected in the movements of the avatar. Research of wearable sensor devices is exploring ways of expanding data collection based on the concept of hand movements, such as by identifying electrical appliances through magnetic sensors. Technology for efficiently and accurately capturing a wide range of phenomena occurring in the real world and technology for making that phenomena easy to understand. NTT Communication Science Laboratories is committed to developing technology for recognizing the real world by extracting useful information from huge amounts of data.